Hi Year 9, so hopefully you have watched the video prior to looking at these notes or watching this video. So pretty much what we're looking at today is trig ratios. You're welcome for the video, by the way. I know you guys would have loved it. Not. Okay, so with our trig ratios, basically there's a special fraction that represents a relationship between two sides of our right-angled triangle. So the shortened version is SOHCAHTOA, so SOHCAHTOA. The word ratio is actually representing a fraction, not the dot that we're used to looking at ratios for, like a 3-to-1 or a 5-to-4 ratio, whatever. So with this SOHCAHTOA, it comes down to sine, cosine, and tangent. Now, these are three functions that you'll learn more about later on. However, for the purpose of this topic, we abbreviate these three words. So sine is actually abbreviated to SIN. Now, it's still pronounced sine, right? Like, even though the E's missing, we still say that's sine, not sin. Okay, so you don't say sin, it's sine. This is cosine, and we abbreviate it to cos. And I've got here, yes, just like the letters, like cos. And then tangent is abbreviated to tan. So we've got sine, cos, and tan, okay? And they come from sine, cosine, and tangent. And you're welcome for this joke, by the way. I really appreciated it. Okay, so here are our ratios. So sine theta, so I've got here, theta represents the angle, the given angle. So sine theta is the opposite side over the hypotenuse. So whatever the length of the opposite side is, over the hypotenuse, which is where the SO comes from, right? Like sine, opposite, over hypotenuse, O and H. Cos theta is the adjacent over the hypotenuse, so the A over H, so the ka. And then the tan is opposite over adjacent, so that's the O over the A, which is toa. So it's so, ka, toa. Okay, you guys are going to have to remember this for the rest of your mathematical career, so I guess you better start remembering it. And to help you remember it, I made up a little song. Well, not a song, but I made up something to try and help you remember it. So it goes a little something like this. Sankey only has cupcakes after her tea or appetizer. Now, I am not a fan of this last line, and I cannot get three words that string together well for T, O, and A. But if you guys come up with something better, let me know. Okay, so it's SOH for so, ka, toa. Sankey only has cupcakes after her tea or appetizer. We will see if that sticks or not. All right, so let's get into the examples. Example 1. In the triangle APX, so remember APX just represents the triangle, find sine theta, cos theta, and tan theta. So with this triangle, notice how we're only using this is our given angle, right? So whatever this angle is, that means we can label our sides accordingly depending on this angle. So remember, for our hypotenuse, it's always the side directly opposite the right angle. So this one here is our hypotenuse. For the adjacent, remember, it's always, well, the opposite's actually easier to do. So the opposite is always opposite the angle that's given to you. So this one down here is 12. That's going to be our opposite side. And that must mean our side that's next to it is the 5. So that's our adjacent side. So with our angles, our sine, cos, and tan, whenever you do this, it's always easier to write SOHCAHTOA at the top of your page, right? So if you write So, or Sankey only has cupcakes after her, and then we did that tea or appetizer. Oh my God, tea or appetizer. So SOHCAHTOA. So for this first one, sine theta is the opposite over the hypotenuse. So we take our opposite side here, which is 12, and that goes on the numerator of our fraction, and then hypotenuse is 13. So it's 12 over 13. And that's the ratio, 12 over 13, right? The next one is cos, and cos theta is adjacent over hypotenuse, so A over H. So we get the A side, or the adjacent, which is 5, then we put it over our hypotenuse, which is 13. And the last one is tan, which is toa. So we've got tan is opposite over adjacent, so 12 over 5. And then we literally just leave it like that, which is so easy. All right, question 2. Find the following trig ratios. So I've got up here, always label your triangle with the sides, okay? So that's nice and easy to do. However, notice here how we want to find the ratios for sine of A, tan of A, but then we go to sine of B and cos of B. So as you can see, when it's talking about A and B, right, this is our triangle ABC. This angle down here makes angle A. This angle down here makes angle B. So I might put that in for you so you don't get confused. So this is angle A. And let's use purple. This is angle, oh wow, I might do that bigger. That is angle B. Angle A and angle B, because it matches the letters. Now, so again, we're going to just write Sokotoa at the top of our page. Or Sankey only has cupcakes after her tea or appetizer. Not a fan of that. I really don't like that. So please help me come up with something better. Okay, so sine of A. That means that we're looking at this angle here. Because it's the opposite over the hypotenuse, we want the opposite side to whatever this angle is down here. So if that's A, we want the opposite, which is going to be 20. So that's going to be 20 over the hypotenuse, which is going to always be 29. Okay, it's the longest and it's opposite the right angle, so it's 29. So that's our opposite over hypotenuse. Again, for tan, this time it's still tan of A, so we want our opposite over adjacent. So obviously, because we're talking about this angle, our opposite side stays the same, and this one has to be our adjacent side. Oh, I don't want to write A because it might confuse you, but so that's going to be our adjacent side, right? So then we've got opposite, which is 20, over the adjacent, which is 21. All right, cos of B this time. So now all our angles change. Because we're talking about angle B, that's this angle down here. So for cos, we want the adjacent over the hypotenuse. So if this is our angle here, again, our hypotenuse does stay the same, but it's the opposite and the adjacents that switch. And that's because if this is now angle B, the angle that is adjacent, the side that is adjacent to angle B has to be this side here, which is 20. So that actually turns to the adjacent side. So it's going to be 20 over the hypotenuse, which is 29. All right, then the last one is angle B. For sine, so it's opposite over hypotenuse. So the one that's opposite is this one now. So we write that as our opposite side. So it's going to be 20 over the hypotenuse, which is 29. And if you can simplify any of these, please do so. Always leave them simplified. All right, the last one. If tan of R is equal to 8 over 15, find the value of sine of R and cos of R. So the first thing we're going to want to do here is, we're going to draw the triangle with the information. So remember, we're only talking about right-angled triangles for this. So what we're going to do is draw our right-angled triangle. Oops. That's annoying. Sorry. Draw our right-angled triangle. And because we're talking about tan of R, right, our angle that is given to us is never our right angle. So you can put that angle R wherever you like. Okay, it can be here or it can be here. I'm just going to put it down here for the sake of it. So we're going to call that angle R. Okay, so because we're talking about, it tells us that tan of R is equal to 8 over 15. Now, from our Sokotoa, the top number has to represent the opposite side because we're talking about tan. And the bottom number has to represent the adjacent side. So if this is our angle R, that means that that side there is going to be our opposite side, right? This side's always going to be hypotenuse because it's opposite the right angle. So let's label that with H. This side is going to be our opposite side. So that's going to be O. And this side is going to be our adjacent side. And that's going to be A. So we can replace these with their actual lengths. So we know that the opposite is going to be 8. And the adjacent is going to be 15. Now we want sine of R and cos of R, right? That's what the question says. Find the value of sine of R and cos of R. But for both of these, right, we're going to need the hypotenuse. So we know the opposite for sine, the opposite side, because we're still talking about angle R, still looking at the opposite, which is 8, over the hypotenuse, which is H. Then the last one is cos of R is the adjacent over the hypotenuse. And we know the adjacent is 15, but we don't know what the H is. For us to find the H, we can use Pythagoras. So remember, H squared, or C squared, is equal to A squared plus B squared, where C is our hypotenuse. So we're going to have literally H squared is equal to, and then remember, it doesn't matter which order you do the other two in. So 8 squared plus 15 squared. Putting that into your calculator, you get 289. But we don't want H squared, we just want H. So we take the square root of that. And we get 17. So then we can go back through and replace all of these H's with 17. So it's 8 over 17 and 15 over 17. So there you go. There you've got our 3 ratios now. Okay, this one was a little bit harder, but I think you guys will be okay with it. All right, good luck.